Hello student, in the last video we discussed the basic part of the Carnot cycle. As we know that it consists of a heat engine. It is a cylinder with a 1 mole of an ideal gas with a source of heat energy at temperature T2, a sink to which we can add the heat energy at temperature T1, and a stand which is insulator. Now these four parts represents a heat engine. Now that heat engine makes a 4 operation. First operation is isothermal reversible expansion, which is represented by the curve AB. Second operation is adiabatic reversible expansion, which is represented by the curve BC. Third operation is isothermal reversible compression, represented by the curve CD. And fourth operation, that is adiabatic reversible compression from D to A. In this way the operations takes place so that the system returns to the initial state through the number of steps, that is the 4 steps, and that's why it is a cyclic process. मागच्या वेळेस आपण याचं बेसिक जे आहे कार्नॉट सायकलचं हे पाहिलेलं आहे. याच्यात एक सिलेंडर आहे ज्याच्यात 1 मोल आयडियल गॅस आहे आणि हे हीट इंजिन म्हणून काम करतो. एक सोर्स आहे त्याचं टेम्परेचर T2 आहे ज्याच्यातून आपण हीट घेतो. सिंक आहे त्याच्यामध्ये आपण हीट एनर्जी टाकतो, त्याचं टेम्परेचर T1 आहे. आणि स्टँड आहे हा इन्सुलेटेड आहे. पहिलं ऑपरेशन केलं आहे आयसोथर्मल रिव्हर्सिबल एक्सपान्शन. हा AB कर्व सांगतो. प्रेशर P1 पासून P2 आलं, V1 पासून V2 आलं. टेम्परेचर आयसोथर्मल असल्यामुळे टेम्परेचर T2 कॉन्स्टंट आहे. सेकंड ऑपरेशन होतं ॲडियाबॅटिक रिव्हर्सिबल एक्सपान्शन. B पासून C पर्यंत आलेलं आहे. प्रेशर P2 टू P3 झालं आहे. व्हॉल्यूम V2 टू V3 झालेलं आहे. आणि ॲडियाबॅटिक असल्यामुळे इथं हीट एनर्जी ॲब्सॉर्ब केले जात नाही, बाहेर टाकल्या जात नाही, परंतु एक्सपान्शन व्हायचं आहे म्हणून स्वतःचीच हीट एनर्जी वापरली, म्हणून इथलं टेम्परेचर T2 पासून T1 पर्यंत डिक्रीज झालेलं आहे. तिसरं ऑपरेशन होतं आयसोथर्मल रिव्हर्सिबल कॉम्प्रेशन. इथं कॉम्प्रेस झालेला आहे गॅस. हा कर्व आहे CD, म्हणून इथं व्हॉल्यूम डिक्रीज झालेलं आहे V3 पासून V4 पर्यंत आणि प्रेशर इन्क्रीज झालेलं आहे P3 पासून P4 पर्यंत. टेम्परेचर कॉन्स्टंट ते T1 आहे. आणि शेवटचं ऑपरेशन आहे ॲडियाबॅटिक रिव्हर्सिबल कॉम्प्रेशन. गॅस कॉम्प्रेस झालेला आहे D पासून E पर्यंत. प्रेशर इन्क्रीज झालेलं आहे P4 टू P1 आणि व्हॉल्यूम डिक्रीज झालेला आहे V4 टू V1. अशा पद्धतीने हे 4 ऑपरेशनमध्ये तुमची सिस्टीम ही पुन्हा जिथून सुरू झाली होती त्या इनिशियल स्टेटला आलेली आहे, म्हणून ही सायक्लिक प्रोसेस आहे. नाउ let us see the mathematical part of this Carnot cycle. Now first operation is isothermal reversible expansion. Now here is the gas which allowed to expand isothermally and reversibly at a constant temperature T2. Volume increases from V1 represented by the point A to the volume V2 represented by point B. As the process is the isothermal, therefore there is no increase or decrease in the temperature. When temperature is the constant, that change in internal energy is also 0, which is also a constant. Delta U is equal to 0. Process isothermal. According to the first law, delta U is equal to Q plus W. As delta U is 0, therefore here we can write Q plus W is equal to 0. Rearrange it. Q is equal to minus W. Suppose this is a first step, therefore Q2 be the heat absorbed by the system and W1 be the work done by the system. Therefore we can write here Q2 is equal to minus W1. Now this is a work done. It is a isothermal reversible expansion. and whenever there is isothermal reversible expansion, as we know that the work done is a maximum type of work done, and it is given by means of the equation W is equal to nRT ln V2 upon V1. V2 is final volume, V1 is initial volume. Now apply that equation to our condition. Here n is 1 because we consider 1 mole of gas, therefore it is no n is here, it is 1. R is there. Temperature of the system is T2, that's why it is T2. ln final volume is V2, initial volume is V1. Final volume V2 है, initial volume V1, and therefore we can write RT2 ln V2 upon V1. Let us equation number 1. बघा ही जी प्रोसेस होती आयसोथर्मल प्रोसेस होती, म्हणून इथलं जे इंटरनल एनर्जी आहे ही 0 आहे. चेंज इन इंटरनल एनर्जी काय 0 आहे. मग चेंज इन इंटरनल एनर्जी जर 0 असेल तर फर्स्टला सांगतो डेल्टा यू इज इक्वल टू क्यू प्लस डब्ल्यू. इथं जर 0 जर ठेवला तर क्यू प्लस डब्ल्यू इज इक्वल टू 0. याला रिअरेंज केलं तर क्यू इज इक्वल टू मायनस डब्ल्यू ठेवला. आपण पहिली स्टेप असल्यामुळे ही जी इथं हीट ॲब्सॉर्ब केलेली आहे सोर्समधून ती घेतलेली आहे Q2, आणि जे वर्क डन झालेलं आहे ते घेतलेलं आहे W1, म्हणून Q2 इज इक्वल टू मायनस W1. हे जे वर्क डन आहे हे वर्क डन आपण 12वीला शिकलेलो आहे. W इज इक्वल टू आयसोथर्मल रिव्हर्सिबल प्रोसेसमध्ये nRT ln V2 upon V1. n is the number of moles, R is the gas constant, T is the absolute temperature, V2 is final volume and V1 is initial volume. इथं अप्लाय केलं जर आपल्या ह्या कंडिशनला तर n इज इक्वल टू 1 असल्यामुळे लिहिलं नाही, R आहे. टेम्परेचर टीच्या ऐवजी इथं T2 आहे. फायनल व्हॉल्यूम V2 आहे, इनिशियल व्हॉल्यूम V1 आहे. वी विल गेट इक्वेशन नंबर 1. नाउ दिस इज द फर्स्ट ऑपरेशन. नाउ द सेकंड ऑपरेशन इज द ॲडियाबॅटिक रिव्हर्सिबल एक्सपान्शन. इथं ॲडियाबॅटिक रिव्हर्सिबल एक्सपान्शन केलेलं आहे. ॲडियाबॅटिकली असल्यामुळे इथं एक्सपान्शन करायचं असेल तर हीट एनर्जी कुठून वापरायची, तर बाहेरून तर घ्यायची नाही, टेम्परेचर तर कॉन्स्टंट ठेवायचं आहे. म्हणून ते स्वतःमधलीच इथं हीट एनर्जी बाहेरून घ्यायची नाही, म्हणून स्वतःमधलीच हीट एनर्जी वापरल्या जाते. स्वतःतली हीट एनर्जी वापरल्यामुळे इथलं जे टेम्परेचर आहे हे T2 पासून T1 पर्यंत डिक्रीज होत आहे, आणि ॲडियाबॅटिक कंडिशन आहे म्हणजे तुमचं जे सिलेंडर आहे हे स्टँडवरती आहे. क्लिअर. नाउ heat is not absorbed, therefore Q is equal to 0. According to the first law, delta U is equal to Q plus W. Q is 0, therefore delta U is equal to W. We will get this equation. As during the expansion, work is done by system on the surrounding. Whenever there is expansion type of work done, work is done by system on surrounding, then it should be a negative, and that's why here we write delta U is equal to minus W according to our conventions. Work is done by system on the surrounding, the work done is a negative type of work done, therefore it is minus W. Let us consider that this is the second step. Work done in the second step is W2, and here we can write delta U is equal to minus W2, equation number 2. But according to the definition of molar heat capacity at constant volume, delta U Cv is equal to delta U by delta T. Delta U is change in internal energy, delta T is change in temperature. Rearrange it for it. Delta U as it is Cv into delta T is equal to Cv. Delta T change in temperature, final temperature minus initial temperature. Here our temperature falls from T2 to T1, that means final is T1, initial is T2, therefore here T1 minus T2. Now from this bracket take negative sign outside the bracket, therefore it is minus. This T1 becomes minus and T2 becomes plus, and here we will get minus Cv into bracket T2 minus T1. इथं मायनस हे बाहेर काढलेले ब्रॅकेटच्या, म्हणून आपलं इक्वेशन काय झालेलं इथं minus W2 is equal to minus Cv T2 minus T1, equation number 3. Now this is about the second operation. Now the third operation, again it is isothermal process. Compression is there is a decrease in the volume. Now the volume decreases from V3 to V4. Initial volume is V3, final volume is V4. Process is isothermal, therefore delta U is equal to 0. According to the first law, delta U is equal to Q plus W, and if delta U is 0, therefore Q plus W is equal to 0, or W is equal to minus Q. W is equal to minus Q. Now this is a third step, and in this third step, if the whatever may be the heat generated, as the process is isothermal, compression is there, that heat is generated, that heat is given to the sink, that amount is Q1, and the process is isothermal, temperature remains at temperature T1, and the work done during the third step is W3, and therefore here we can write the equation 4 like this: minus Q1 is equal to W3, and again isothermal reversible process is there. Here we get RT1, that is nRT is equal to nRT ln V2 by V1. N is 1, therefore it is not written here. R is gas constant, temperature is T1. This process is carried out isothermally at temperature T1, therefore here T1 ln final volume is V4, initial volume is V3, and therefore we will get equation minus Q1 is equal to Q3 is equal to RT1 ln V4 by V3, equation number 4. Now the fourth and last operation, adiabatic reversible compression. Adiabatic condition, no heat is absorbed. If heat is not absorbed, compression is there, therefore there is increase in temperature. Temperature increases from T1 to T2. Heat is not absorbed, therefore Q is equal to 0. According to the first law, delta U is equal to W. Let the work done in the fourth step is W4, therefore we can write minus delta, it is delta U is equal to W4, equation number 6. Now again, according to the definition of CV, that is molar heat capacity at constant volume, it is equal to delta U by delta T. Rearrange for it, delta U, change in internal energy is equal to CV into delta T. Delta T is a change in temperature, final minus initial T2 minus T1, and here we get, put the value in the equation 6, we will get W4 is equal to CV T2 minus T1, equation number 7. We will get these main equations, that is the equation number 1, Q2 is equal to minus W1 is equal to RT2 ln V2 by V1. Equation number 3, equation number 5, and equation number 7. These are the main 4 equations we get during the 4 different operations. Now the net work done is given by the total work done. W is equal to work done in first step, work done in second step, work done in third step, plus work done in fourth step. The summation of all these 4 work done, we will get the net work done. In first step is minus W1, in second step is minus W2, third step is W3, and fourth step is W4. Now put the value of minus W1 from equation number 1, minus W2 from equation number 3, W3 from equation number 5, and W4 from equation number 7. आपल्याला टोटल वर्क डन काढायचं असेल तर प्रत्येक स्टेप मधल्या वर्क डनची बेरीज घेतली आणि त्याच्या ज्या व्हॅल्यू आहेत त्या व्हॅल्यू इथे ठेवलेल्या आहेत. आता याच्यामध्ये हे मायनस CV T2 मायनस T1 आहे आणि हे प्लस CV T2 मायनस T1, हे दोन्ही टर्म कॅन्सल झाले, उरले ह्या 2 टर्म्स इथे. W इज इक्वल टू RT2 ln V2 by V1 प्लस RT1 ln V4 by V3. इथं थोडा एक मॅथमॅटिकल चेंज केला, हा जो रेशो आहे हा रिव्हर्स केला तर हे होते 10 रेज टू पॉवर -1, आणि जे -1 आहे ते जर इकडे आणलं लॉग रिथमचा रूल वापरून तर मायनस आणि हे प्लस, तर हे मायनस होईल. म्हणून इक्वेशन झालं W इज इक्वल टू RT2 ln V2 by V1 मायनस RT1 ln V3 by V4, इक्वेशन नंबर 8. clear, we will get equation 8. This is the net work done. Similarly, the net heat absorbed by the gas during the cyclic process is given by, we know that this is a cyclic process, but heat is absorbed in a step, that is the first step and the third step. We will get, in the first step heat is absorbed, in the third step heat is given out, and therefore the net heat absorbed will be given as Q is equal to Q2 plus into bracket minus Q1. If you put the values of Q2, the value of Q2 from equation number 1, now this is Q2, and the value of minus Q1 from equation number 5, put the values, here we put the values, again same thing, inverse this ratio V4 by V3, याच्याऐवजी V3 by V4 लिहिलं तर याचा पॉवर -1 होतं, लॉगरिथमचा रूल वापरला -1, इकडं मल्टिप्लिकेशन आलं तर हे मायनस होतं, म्हणून इक्वेशन झालं Q इज इक्वल टू RT2 ln V2 by V1 minus RT1 ln V3 by V4, equation number 9. Now if we compare the equation number 8 and equation number 9, the right hand side of both the equation is same, therefore we can write W is equal to Q from equation 8 and 9. This shows that, or it shows that, the net work done in cyclic process is equal to net heat absorbed. It is equal to net heat absorbed. What is the net heat absorbed? The total heat absorbed is Q2. Out of that, Q1 is given out. Remaining heat is a net heat, which is converted into the work done. Now clear? Now this is the second step. First step is the 4 operations. Second step, we have to prove that W is equal to Q, and then the next step. Here, for adiabatic condition, T into V, that is temperature into volume raised to power gamma minus 1 is equal to constant. Now this is a condition for a adiabatic. Whenever there is adiabatic condition, now at that time the temperature into volume raised to power gamma minus 1 is equal to constant. By using this equation, we can apply this term to the adiabatic points, and we will get equation number 10. Now let us see how that equation 10 is obtained. Now here is the now see, this is the first operation at the point adiabatic condition, and from B to C there is adiabatic. At the point, what is temperature? It is T2. What is volume? V2 raised to power gamma minus 1 is equal to constant. And at the point C, temperature is T1 and the volume is V3 raised to power gamma minus 1 is equal to constant. If you equalize these two terms, we will get equation number 1, that is T2 V2 gamma minus 1 is equal to T1 V3 gamma minus 1, equation number 1, as point B and point C is on the same curve, that is the adiabatic curve. Therefore, for that point B and C, we can write equation number 1. Similarly, there is adiabatic condition along the curve AD. Therefore, at point A, it is T2 V1 gamma minus 1. Here is the T1 V4 gamma minus 1. T1 V4 gamma minus 1. We will get equation number 2. These two equations can be equalized as they are on the same adiabatic curve. We will get equation 1 and equation 2. Divide equation 1 by equation 2. If we divide equation 1, equation 2, we will get this equation. Now in this equation, whatever may be the common thing get cancelled. Here T2 get cancelled, T1 get cancelled. We will get this equation. Now the power is same. या इक्वेशन मध्ये याचा घातांक सारखा आहे, याचा घातांक सारखा आहे, म्हणून याला कॉमन केलं V2 by V1 raised to power gamma minus 1, here V3 by V4 raised to power gamma minus 1. Now again on both sides power is the same, therefore base can be same, and here we can write V2 by V1 is equal to V3 by V4 by applying the adiabatic condition, that is this TV gamma raised to power gamma minus 1 is equal to constant. We will get V2 by V1 is equal to V3 by V4. We will get this equation. Now here is the equation for the adiabatic condition. Since for adiabatic TV raised to power gamma minus 1 constant, hence we will get V2 by V1 V3 by V4, equation number 10. Clear? Now this is the equation number 10. Now from equation 10 and equation 8, now this is equation 8. Here is V2 by V1, here is the V3 by V4. Now instead of V3 by V4, we can write V2 by V1 from equation number 10, and we will get equation Q is equal to RT2 ln V2 by V1 minus RT1 ln V2 by V1. Now R is common, ln V2 by V1 is common, and there is a in bracket T2 minus T1. We will get equation number 11, that is Q is equal to R into bracket T2 minus T1 ln V2 by V1. आपल्याला इक्वेशन नंबर 11 मिळालेला आहे. इथं काय केलं आपण इक्वेशन 8 मध्ये V3 बाय V4 च्या जागी काय ठेवलं, V2 बाय V1 ठेवलं, म्हणून आपल्याला इक्वेशन 11 आलं. Clear? Equation 11. Now let us see the equation number 1. What is the equation number 1? Q2 is equal to RT2 ln V2 by V1. याला आपण थोडं रिअरेंज केलं. हे T2 जर लेफ्ट साइडला आणलं तर इथं होतं Q2 by T2 is equal to R ln V2 by V1. Now same thing is there. From this equation number 1, Q2 is equal to RT2 ln V2 by V1. Rearrange it. Q2 by T2 is equal to R ln V2 by V1, equation number 12. Now from equation 11 and 12, instead of R ln V2 by V1, we can write, now here is the Q. Now Q is equal to W, therefore we can say that W is equal to R T2 minus T1 ln V2 by V1. Now from this equation 11 and from equation number 12, here we can write W is equal to T2 minus T1 into Q2 upon T2. Now transfer this Q2 on this side. W upon Q2 is equal to T2 minus T1 upon T2, equation number 13. Now we know that the work done and the heat absorbed from the source, the ratio is called as efficiency, and therefore eta is equal to T2 minus T1 upon T2, where eta is efficiency, it is W upon Q2. Now this equation number 13 and equation number 14 gives the efficiency of the heat engine. Now if you observe the equation 13 and 14, it is clear that this T2 minus T1 upon T2 is less than 1, as well as this W is less than Q2. This means that work done is less than that of the heat absorbed. याच्यावरून काय लक्षात येतं आहे की तुमचं जे वर्क डन आहे हे कशापेक्षा कमी आहे, हीट ॲब्सॉर्ब पेक्षा. याचा अर्थ काय, only a part of heat absorbed by the system at higher temperature T2 is transferred into the work. The rest of the heat Q1 is given out by the system to the surrounding when it is in the lower temperature. It is at the lower temperature. याचा अर्थ तुम्ही जी हीट ॲब्सॉर्ब केलेली होती Q2 ही जशाची तशी वर्क डन मध्ये कन्वर्ट झालेली नाही. त्यातला काही पार्ट म्हणजे Q1 अमाऊंट ही तुम्ही कुठं दिलेली आहे, सराउंडिंगला दिलेली आहे. आणि हेच आहे एक स्टेटमेंट सेकंड लॉ ऑफ thermodynamics. In this way, in the Carnot cycle, we derive an equation for efficiency. Now this is the equation for the efficiency. We prove that in the cyclic process, net work done is equal to net heat absorbed. आपण इथं प्रूव्ह केलं की नेट वर्क डन आणि नेट हीट ॲब्सॉर्ब हे काय आहे, इक्वल आहे. In this way, we discuss the total Carnot cycle today. This is about the Carnot cycle. Now we will stop here. Thank you.